So what I'm going to do is this video, even though this slide says 5.4, solving right triangles, the last two slides of this video are really 5.3, part C. Okay, so the last two slides. Okay, and so really all I'm going to do is I'm going to skip through, and we're just going to have this 5.3 part C video focusing on the last two slides. The first slides 1 through 6 for 5.4, this section, will be in your 5.4 video. Okay, so this is just focusing on the last two slides, which are going to be 5.3 part C. So here we're going to have the video for, this is 5.3 part C. Okay, this is the third part of it, where we're going to focus on using our calculator to find some trig values. So when we find the secant of 31.67, remember that what we were focusing on the other day was we found sine and cosine and tangent of numbers, and we've used our calculators. The other day we learned to use basically 30, 60, and 45, right? Where we could find all these trig values on our own without a calculator. But what do we do when we want to find a value like this? Well, we can't use those other values, you know, and not use our calculator. We have to use the calculator for this, yet our calculator doesn't have a secant button. And so that's the problem. Our calculator has sine, cosine, and tangent buttons, and it also has inverse sine, inverse cosine, and inverse tangent. It doesn't have secant, cosecant, cotangent. So it's really important that you remember your reciprocals. You know that secant goes with cosine, you know that cosecant goes with sine, and you know that cotangent goes with tangent. So when you're going to plug this into your calculator, it says sine of 31 or secant of 31.67 degrees. Well, we know that the secant of theta is 1 over the cosine of theta. Theta is the unknown angle. Here we have an angle, so we can do this. We can say the secant of 31.67 is equal to 1 over the cosine of 31.67 degrees. And so all you need to do is go to your calculator, make sure you know how to use your calculator, and you're going to do 1 divided by, and you're going to do the cosine of 31.67. And you should get 1.1749, and it tells you to round to 3 decimal places, so it's approximately 1.175. And so this is the secant of 31.67 degrees. And again, you want to check yourself, because you want to make sure, number one, that the value makes sense. Remember, secant and cosecant are either greater than 1 or less than -1, so the value is in the correct range. You also want to think about the fact that this angle is in quadrant 1, okay? And you want to know, is the secant a positive value in quadrant 1? And it is. Remember that in quadrant 1, all of our trig functions are positive. And so, yes, it makes sense that it's positive as well. So check your answers, make sure they make sense, make sure they follow the rules they're supposed to. But that's how you do it. So I'm going to go to number 9. And in number 9, again, it's the cotangent of 81.8 degrees. Well, that's also a value in quadrant 1. That's an angle in quadrant 1. We know that the cotangent of an angle, theta, is equal to 1 over the tangent of theta. So it would make sense then in this problem, right, that the cotangent of 81.8 degrees is equal to 1 over the tangent of 81.8 degrees. So again, you go to your calculator, 1 divided by the tangent of 81.8, and it gets you to 0.1441. And again, round to 3 places, 0.144, and this is the answer. And again, make sure it makes sense. is the cotangent positive in the first quadrant? Yes, everything is positive in the first quadrant, so the positive part makes sense, and the value, tangent can be anything. It doesn't have a range, like sine and cosine, like we talked about. And then the last one is this one. It asks you for the cosecant of 131 degrees, 45 minutes, and 25 seconds. So obviously we have to convert this first to a degree measure. So we know that this is 131 plus 45 over 60 plus 25 over 3600. When I do the math, it's going to be 131 plus 0.75 plus 0.00, and I believe it's 69. Let me see. Yep. And I'm going to add those together. So I'm going to add 0.75 to that plus 131, and I'm going to get 131.7569. And I'm going to leave it to 4 places. Nothing wrong with that. So now I'm here, I'm going to look for the cosecant of 131.7569 degrees. Now, I know that the cosecant of theta is equal to 1 over the sine of theta. So that means the cosecant of 131.7569 degrees is equal to 1 over the sine of that number. 7569 degrees. Well, that's kind of messy. Okay. So I come over to my calculator, 1 divided by the sine of 131.7569, and I get 1.3405, and again it's going to be 1.34. And so I have this, I have the cosecant of this number is positive, of this degree is positive 1.34. Well, let's look at that. First of all, the cosecant is always above 1 or below -1, so it's in range. The second thing is this is in quadrant 2. Okay, so I'm looking for in quadrant 2, right? What should my cosecant be, positive or negative? Well, in quadrant 2, notice that the sine and the cosecant are positive, so this is accurate and correct. And so that's how you do it. So I know there's a lot going on here, but in the end, it's pretty straightforward. You're given the degree, and all you have to do is use the, in this case, use the reciprocal identities to plug them into your calculator so that you can use sine, cosine, and tangent in the calculator. Now, when we come to this page, it gets a little bit more challenging because in the last slide, it was very straightforward. You were asked to find the sine or the cosine or whatever the trig value was of a particular angle. Here, you're given the actual sine of a number or the tangent of a number, of an angle measure, a cotangent and another cotangent. You're given those values, and we're asking you, what is the angle measure that gives you that? So you're going to be using inverse functions here. Remember, when you're looking for angle measures, you're going to be using inverses. The other thing is you need to realize that just like we did the other day, remember when we were drawing them on our own, we were using reference angles. That's kind of what we're doing here. But we were using reference angles that we could do without a calculator, and those were 45, 30, and 60. And remember that we talked about the fact, for example, if the sine was, like, if I tell you the sine of a half, okay, what is the, or let's just do this. Let's say I ask you if sine theta equals a half, okay, what's the angle measure? Well, we remember, if you remember, a 30-degree angle, right, is going to be the 1 here, the side opposite the 60 is radical 3, and the hypotenuse is 2. And you realize that the sine of 30 degrees equals 1 over 2, opposite over hypotenuse. And so we know that 30 degrees is one angle that's going to give us a sine of a half, a positive a half. However, it isn't the only one, because the sine is positive in quadrant 1, in quadrant 2, not 3, or not 4. But I know in quadrant 2, if I have this reference angle of 30 degrees, I'm also going to have, notice, I'm going to have the sine of that one is also a positive a half. Well, what angle is that? Well, that angle's formed by this here. And so if you remember, 30 degrees is our reference angle, but this angle here is 150. So we had formulas on how we could find these reference angles, right? Once we know the reference angle, we could find the angles in each quadrant. Remember that in quadrant 1, the reference angle is the angle given, okay? It's just itself. In quadrant 2, 180 minus the reference angle is the angle we're looking for, right? In quadrant 3, it was 180 plus the reference angle equals the angle that we're looking for. And in quadrant 4, it was 360 minus the reference angle equals the angle in that quadrant. So it was a kind of a formula, and I taught you, like I can kind of draw it out a little bit better, but when you get to these problems, it's probably better to memorize these formulas. And so let's kind of walk you through, now that we sort of know, let's do another one, right? That isn't one that you can draw out and kind of use those 1 and radical 3 and 2 and all that, right? We're going to use one that we need our calculator for. So again here, I'm going to do my thing here, and I'm going to say, okay, they're asking you the sine theta, what angle measure has a positive sine of 0.6746? So first of all, in what quadrant is your sine positive? And again, remember, it's all students take calculus. So I know that it is in quadrant 1 and 2 where the sine is positive, the sine is negative in 3 and 4. So I know my angle is going to be in quadrant 1 or 2. So when I go to my calculator, I'm going to do the inverse sine of 0.67456. And that's going to give me my first angle. Okay, so I'm going to do 0.67456. And I'm going to do second sine, and I'm going to get 42.4 degrees. It wants me to round to 3 decimal places, so 4199, which is approximately 42.42 degrees. Okay, so I know that in this quadrant, 42.42 degrees is my angle that's going to have that sine. And I know then that I have to take it to this quadrant as well. If my reference angle is 42.42, then what's this angle? Well, remember that in this quadrant, it's 180 minus the reference angle, and that's going to give me the other degree measure. So 180 minus 42.42, and that tells me that 137.58 degrees is going to be the angle, the second angle measure that will give me the same sine. So these are the two values, these are the two angle measures that give me a sine of 0.67456. Okay? And so again, it really requires that you understand the quadrants and where will those values be positive or negative. As we go doing more, I think it'll make more and more sense each time, okay guys? It does take a little while. So these reference angles, 45, 30, and 60 that I had up there, those are the ones you're going to do without calculators. These are with a calculator. So now I come over to here, and I know, again, the tangent of theta is 1.45. So again, let's kind of go over to here. All students take calculus, and ask ourselves, where will the tangent of a degree, what quadrant will the tangents be positive? Well, the tangents are positive in quadrant 1 and quadrant 3. Tangent is negative in the other two. So I know my answer is going to be in those two quadrants. My two angles are going to come from those quadrants. So now I'm going to do the inverse tangent of 1.45, and I'm going to get my first degree measure. So again, I'm going to do 1.45 inverse tangent of that number, and I'm going to get 1.45. My calculator doesn't want to work, sorry guys. Inverse tangent. Okay, so I have 55.4077. And again, they want me to round to 3 decimal places, right? So 55.408 degrees. So 55.408 degrees is going to be my first angle here in this quadrant, 55.408 degrees. That's going to give me a tangent of 1.45. And you can double check yourself, type in your calculator, what is the tangent of 55.408? When you do that, 55.408, and you hit the tangent button, you should get 1.45, and we do. So we have our first degree measure, our first theta angle that has a tangent of 1.45, and that's in quadrant 1. So now we have to find an angle that ends in quadrant 3 that has that same reference angle. So again, I know I've got to kind of come from here, end here in quadrant 3, and this part here has to be 55.408. So in this quadrant, what we do is we do 180, because we start here and we go to 180, plus another 55.408. So 180 plus 55.408, and we get, when we do the math, 235.408 degrees. Okay, so this is the second angle that gives us that tangent. And so again, I found my two solutions. So again, my two solutions for the first problem are 42.42, and this is 137.58. And my two solutions in the second problem are these two angles here. Both of those angles have a tangent of 1.45. Again, we keep going. Now this is a little bit more difficult yet, even more so, because here we were looking for sine, which the inverse sine button is on our calculator. Here we're looking for tangent of an angle, and again the inverse tangent button is in the calculator. However, now we have a cotangent problem, and guess what? The cotangent is not on our calculator. Okay, so that makes it a little bit harder, but remember that we have a reciprocal function that says the tangent of theta is equal to 1 over the cotangent of theta. Okay, so I know that the tangent of theta is going to be equal to 1 over whatever the cotangent of theta is, so that means 1.27893. And so if I want the actual angle measure, I'm going to have to do the inverse of that, right? So I'm going to have to do the inverse of 1 divided by 1.27893. And that should give me my first angle measure. So, again, however your calculator works, 1 divided by 1.27893. I'm going to get that decimal, which is like 0.7819, whatever, and I'm going to get the inverse tangent of that. And I'm going to get 38.022 degrees. And so that is my first angle measure. Now, again, before I start, I forgot to look at the quadrants, right? So again, let me come back up here. I know in the first quadrant, so all students take calculus, and I see that my cotangent is positive. Well, tangent and cotangent are positive in the first and third quadrants, so I know that my first angle is going to be in quadrant 1. The calculator always gives you the answer in quadrant 1. So I know that this is my first value here, and I'll draw it out here, right? And so I know this angle here, 38.022, this angle is going to have that cotangent, or that angle measure is going to have, its cotangent is going to be 1.27893. And then which other one's going to give me that value? Well, again, I have to go to quadrant 3. So I go to here, and I know this angle here is 38.022. That's my reference angle. So what angle is going to give me that reference angle? Well, it's going to be 180 plus 38.022. So 180 plus 38.022 is going to be 218.022 degrees. And so that's my second angle. So again, once you understand it and you really understand what you're doing with the reference angles and how they work, it really becomes easier and easier. And so the last one, it's still the same cotangent of 1.27, except it's negative. So I have to think about that, right? Because again, it's a negative question here. So how do we do that? Well, if I just go to my calculator, I want to show you something. But again, remember that I've got all students take calculus, and so I know that my tangent is negative in the second and the fourth quadrant. So this answer is going to come from that. If I just do the math here, I do tangent theta equals 1 over the cotangent of theta. That means tangent theta equals 1 over negative 1.27893, right? And I know then that the inverse, because I'm looking for the degree, is going to be this. If I do the math like this, and I find my inverse tangent, I'm going to do 1 divided by, it's going to be 1.27893, but the negative of it, you're going to see that when you do the inverse, you're going to get negative 38.022 degrees. So if I come over to my graph here and I do negative 38.022 degrees, right? Remember, negative is just the direction this way, right? That's fine and dandy, but the problem is that we don't want, notice my interval here, I don't want a negative degree, okay? They want the degree measure that is going to be between 0 and 360, not negative. So I have to think about, well, what angle, what positive angle is coterminal with here? And so I know basically what this really means is that my reference angle in this case is always just 38.022. So I just have to figure out, well, what is the angle in quadrant 2 and 4 that works with this reference angle? So I don't really need to think of it as negative or positive. I just have to think of the reference angle as 38.22, just like it was up here. So in this quadrant, it's going to be 360 minus 38.022. So again, that angle is going to be 360 minus 38.022, and that's going to be 321.978 degrees. That's one solution. And in quadrant 2, again, my reference angle is 38.022. So what is this angle, this red angle? Well, in this quadrant, remember, it's 180 minus the reference angle. So that's how I'm going to get the angle in the second quadrant. So 180 minus 38.022. And it's going to be 141.978 degrees. So the answer for this one is 141.978 degrees and 321.978 degrees. This is in quadrant 2. This one's in quadrant 4, because those are the two quadrants that will give me a negative cotangent. Okay, so again, kind of weird, I get it, but if you practice it enough, you'll get very comfortable with finding it. And ultimately, what you're really looking for are these reference angles, because once you have the reference angle, then, the reference angle in quadrant 1 is the angle itself. But then in all the other quadrants, you're just going to add, you're going to subtract that reference angle from 180 in quadrant 2. In quadrant 3, you're going to add it to 180. And in quadrant 4, you're going to subtract it from 360. And that's how you're going to get these values. Okay? So just kind of remember these parts of the formula because they're really important. And that's it for this video.